All right, a little review in case you're struggling with factoring. So this is going to be all about how to deal with factoring problems. Now, I'm going to use some problems that have a values other than 1 in here, but we know that on our test you wouldn't actually be asked to do that with a number that's something other than 1. So I don't know how I managed to do that, but all right, there we go. So when we're setting up factoring, first things first, we have to know how to organize everything. So the x squared piece is always going to go in the upper left of your box here. And the number by itself, the c value, will always go in the bottom right. What we have to figure out is how we're dividing up this negative 11x into each of the 2 boxes in order to make this problem work out. Because what we're looking for is what goes on the outside edges, what goes up here and what goes out here that multiplies in to make this 30x down here and makes 2 pieces so that these 2 pieces become negative 11x. So how we did it in class is we split this we made the diamond method. And how it worked is that an a value times a c value went on top. So 1 times 30, and then your b value went on the bottom. So what we're looking for is 2 numbers that not only multiply to 30, but also add to negative 11. Now, if you can figure them out right away, great. Otherwise, what I like to do is write out a list of all the factors. Now, since I know I'm multiplying to a positive and adding to a negative, I know I'm multiplying 2 negatives together. So my choices would be negative 1 times negative 30, negative 2 times negative 15, negative 3 times negative 10, or negative 5 times negative 6. Those are my only options. So then I go through and I figure out which number pair off that list would add to negative 11. This adds to negative 31, that adds to negative 17. This is close, it only adds to negative 13. The only one that does both, multiplying to positive 30 and adding to negative 11, is those 2 numbers. So what that's telling me is that I'm splitting that negative 11x into pieces of negative 6x and negative 5x. Once I've split that out, what we kind of do is, this is the way I like to imagine it, is to cover up the entire side of the box. So it's almost like it's not there for a minute. And say, what is the common piece here? What are these both divisible by in order to figure out what's going to go on the top of the box? Generally speaking, it should be an x of some kind. In this case, it's just a single x, because both of these pieces would be divisible by that. Once I know what goes here, I'm going to work my way around the side and say, what times x gives me this x squared? Well, that would just have to be x, because x times x is x squared. Then I say, what times x would give me negative 6x? And that would have to be negative 6. Once I have those 3 pieces in place, only then do I move the screen over and look at what's left and say, okay, what do I need to multiply x by to make negative 5x? And in this case, it would have been negative 5. And then just to make sure I did everything right, I'm going to check and say, does negative 6 times negative 5 give me this positive 30? Which it does. So my factors are exactly what we see on the outside of the box. The x minus 5 times the x minus 6. So x minus 5, x minus 6. So this would be considered factored form. However, it's not our solution. Our solution actually comes out of what's inside of each parenthesis, meaning what does x need to be so that x minus 5 is 0? Usually what it's going to end up being is just the opposite of what you see. So x would have to be positive 5 because 5 minus 5 is 0. And x would have to be 6 because 6 minus 6 would also be 0. So these are my 2 solutions. Let's try that again, but with an a value this time. So I have 2x squared. The x squared piece always goes in the upper left. The c value, the piece by itself, goes in the bottom right. And in our diamond, a times c in this case would be 2 times 16, which is 32. The b value goes on the bottom, 18. So I'm looking for 2 numbers that multiply to 32 and add to 18. Since I'm multiplying to a positive and adding to a positive, I know my options have to be 2 positive numbers. So 1 times 32, 2 times 16, 3 doesn't work, 4 times 8, 5 and 6 don't work. So those are our only options. So then I say, which pair adds to 18? Well, it should be this middle pair, 2 and 16. So that means in these boxes, I'm going to put in 2x and 16x. Again, covering up the box so that I can only see one piece at a time. What's the common factor here? Well, yes, they're both divisible by x, but they're also both divisible by 2. This is where it becomes extremely important to pay attention to what you're doing, because I have to figure out what times 2x makes 2x squared. It should not be 2 over here. If I wrote down a 2, 2 times 2 doesn't multiply to make 2, it makes 4. So I know it can't have a 2 out here, but it should have an x. Then I say, what do I multiply 2x by to make 16x? And I get 8. Now I've got those 3 pieces in place. I can check the other piece. So x times what makes 2x? That would have to be 2. And just to check my work, 8 times 2 does make 16. So my factors end up being 2x plus 2, x plus 8. Now if you tried to do this problem on your own, you might have gotten a different answer. You might have also gotten x plus 1 times 2x plus 16. Technically, both answers are right. What we talked about in class is that when you have these parentheses where there's a number in front of the x, you need to check and make sure that this parenthesis can't be factored out, meaning there's not something I could divide out of this factor. In this case, there is. I can pull a 2 out of both pieces, so that actually can be rewritten as 2 times x plus 1, x plus 8. So I can rewrite it as that. This one I can do the same thing. I can pull a 2 out of the second parenthesis, and I'm left with x plus 1 and x plus 8. That's why the answers are the same. We get the same thing in the end. In this case, we still have to come up with our factors. So the 2 doesn't affect anything. I say what plus 1 works out to 0, in this case negative 1, and what plus 8 works out to 0, in this case negative 8. So not only do you need to pull all the numbers out and make sure you're completely factored, then you also need to find your solutions. One more time. X squared piece goes in the upper left. C value goes in the bottom right. I need 2 numbers that multiply, in this case, to make negative 72, and add to make our B value of negative 1. So in case you forgot, that was A times C for the top, so 3 times negative 24. B value for the bottom. Now I'm multiplying to a negative and adding to a negative, so that means I need a positive times a negative. So negative 1 times 72, negative 2 times 36, negative 3 times 24, negative 4 times 18, 5 doesn't work, negative 6 times 12, 7 doesn't work, negative 8 times 9, and then we can start working in reverse. This one has quite a list of factors. Hopefully you've already figured out which factor pair it is. Then we would go through the list and say which pair here adds to negative 1. It would have to be this pair because negative 9 plus 8 makes negative 1. So those are going to be what go in our side boxes. Again, we cover up the whole thing and ignore what's going on in the second half at first. Say, what's the common factor here? They're both divisible by x, but they're also both divisible by 3. Once I've done that, figure out what goes here. In this case, it would have to be x. And what would need to go here? In this case, it would be negative 3. And then I can uncover and figure out what needs to go on the other piece. So what times x makes 8x? It would be 8. And then checking my math, negative 3 times 8 gives me negative 24 like I need. So my factors should be 3x plus 8, x minus 3, meaning my solutions should be 3 and negative 8 over 3.